have the energy this afternoon because we're going to talk about something really important and crucial in our app development. It's about databases, and I hope you will learn a lot through the session. So let's get started with it. I'm going to talk about Firebase Advanced Queries. Now, one thing that you really have to think about when you're developing your app is how you structure your data, right? Because at the end of the day, your application development will determine on what data you want to show to your users. And that is the reason why sometimes we create our database design and we iterate. Because we realize at the end of the day, like, oh, I actually want to show my users this. Oh, I actually can still improve this. And so there's so many iterations that goes throughout a database design. And that can be really time consuming, right? So there's something called view-based approach. That means your database design is highly influenced by what you want your users to see in your application. So that's what also I'm going to be talking to you about, like how do we actually implement this view-based approach? And Firebase understands this. That's why Firebase also makes it easier for us developers to perform simple and complex queries to accommodate the view-based approach. So, what better way to illustrate that than to have an actual project application, right? Let's say we are actually creating Friendly Eats. So Friendly Eats is a restaurant review app. So you have a restaurant and people actually dine on them and have their insights about the restaurant, and also users that serves as the author of those reviews. How do we actually visualize that in a Firestore database? This seems to be the perfect collections that you're going to make, right? You will have users that can write reviews. You have restaurants that actually you as a food lover or someone who just wants to dine would view. And then you have ratings for you to actually give your verdict if that restaurant is actually good or not. And here, just as I mentioned, the view defines the collection. So in every page or in every view of your application, what do you want your users to see? What type of data do you want to display? So firstly, we can probably have this list of restaurants, and of course we can have lots of restaurants, right? In Indonesia alone, I think you have like thousands of restaurants out there. So the first thing that we may want to show to our users is, like a limited list. We can paginate all of these restaurant records, limited to 10. So that's how you actually code this specific query. We have to get the restaurants and limit it by 10. And if you want to move to the next page, you can implement the skip command to actually proceed to the next rows of data that you want to display. How about filters, right? Like there are many things that you want to see in a restaurant. It could be like you want to filter it by city or by category. So we could probably evolve that specific view to this type of search results page. And here, just as how we did the query before, we can also query restaurants by city. So there we have where city equals what parameter you are passing. So here we have the example of Topeka. So it will return all of the restaurants that are in Topeka based also on the fields and the values that we have on that specific record. And also for categories, right? Still same. But here it's a bit of, we have array contains here. Array contains actually lets us query multiple values. For example, you want to query for a specific category for tapas and some other cuisine, right? It can also return that with the array contains keyword in the where clause. of our query. Next, also for restaurants, restaurants for cities, right? We have the in keyword there, wherein you can actually also have multiple, can have an array of cities, and it can also return these restaurants with these specific cities that you want to query in. And here, we can also implement any category. So get restaurants for any categories. So same with what we showed before, it's cities, but now it's for the categories. So we have also the array contains any clause there that we can put as a parameter to our where query. And just as how you also perform AND and OR queries in normal SQL database, Firestore can also do that. So here, what if we want to query all of the restaurants? Either you put the keyword for city or you put the keyword for category. So this is how you construct the query for that. And also, apart from the OR, we also have the AND, right? You want to query, for example, in Jakarta, and then like what type of food, category of food, that can also be returned as a query result. So here, another view that we may probably want to show the users apart from the search results view. We may want to show them a single restaurant, right, that shows the record or the details of that specific restaurant. And of course, the most important thing is the ratings, right? Because we wanted to know if a restaurant is good or not. So it just makes sense that since rating is actually a separate collection from our database design, it just makes sense that this rating is actually a sub-collection of our restaurants collection. So how do we actually implement that in query? Because Firestore actually implements shallow query. That means from the root collection, it doesn't automatically fetch all of the data that is inside the sub-collection. How do we implement that? So this is an example of that. In the first two lines inside the function, we're basically getting the details of that specific restaurant. And then in the succeeding, let's say fourth and fifth line, we're actually populating the ratings for that specific restaurant, and then we're actually mapping it so that it will be returned as a response. So you have there the details of the restaurant and the ratings for that specific restaurant. Okay, another thing that we want to show are users. So what if we want, I'm a user, I logged in, and I want to see all of the reviews that I make for any type of restaurant, right? So that seems to be the same view with the restaurants, just as now it's users, right? So we are actually torn between, should we also put the ratings as a sub-collection to our users? And you may think that, oh, we're actually putting so many sub-collections of ratings. It's already in the users and restaurants. Isn't that like a bad database design? So in NoSQL, we have this thing called denormalization. So denormalization means you're putting data redundancy in some parts of your database to optimize your read operations. Because it's not all the time that denormalization is bad, right? What if your app actually performs more read operations than your write operations? Then denormalization process actually makes sense in that. But here, denormalization also has its disadvantage. What if you want to update records, right? Because you have so many scattered redundant data in your database, updating them becomes a problem. And so here, we have to choose between, should we put the ratings as a sub-collection to the users collection, or should we put it on the restaurants instead? We have to weigh in. Which actually gets more read operation? Does our user often go to their profile and check the ratings, or is it like what the, isn't like our user just going to look at any restaurant and check the reviews. Of course, users would look more into the restaurants, right? And that is why, instead of having these two, we will just have restaurants and have their ratings as their sub-collection. Okay, back to this one. How do we actually implement that in query? So here we have this thing called collection group. So collection group means instead of accessing the root collection, you're actually treating the sub-collection like a root collection. But since you are doing this in an index search, you have to specify this in the Firestore setting, which type of field actually becomes the index. And from there, you'll be able to query it without going through the root collection. So here, then what if we wanted to show the average ratings, like this restaurant have many ratings, right? And we wanted to compute what is the average rating for it. That sounds like an aggregation query, right? So aggregation means if you want to count something in your database and also compute that. So Firestore actually supports that as well. So here we have an aggregate. We can aggregate it and also compute it. Like we will scan through the database for all of this rating record and perform an average of it. And you can actually look more into how you can perform simple and compound queries in the official documentation of Firestore. And the point really here is to show you that Firestore has evolved so much. It can already top up with the most sophisticated cloud databases out there. So if you have a project, you can definitely consider Firestore because it gives you more power in terms of querying. It can also give you more functionalities, and it's constantly improving and evolving. And so that basically ends my presentation. I hope it gave you an understanding of how you can query faster and more. It can give you more ideas on what other types of keywords you can use for your querying in Firestore. Yeah, terima kasih, and I hope you learned